Okay, this is lesson 72, operations of functions. It's pretty simple. There's just a new operation that can get a little confusing sometimes. So let's just start with two lines. Let's take a line that says f of x is equal to 2x plus 1, and g of x is equal to 3x minus 4. Now we know we can graph them. We can see where they cross. We can see they're not the same slope, positive slope. Y-intercept is 1, positive 3 slope, y-intercept is negative 4. But we actually can take these two functions and we can add them together. Any two functions that you have and you're especially interested in like terms, that's what you're looking at. So if I want to add, look how we can write this. And there's actually two ways. You can do f of x plus g of x. And f of x is 2x plus 1. It's just a line. And we can add to that g of x, and if you feel more comfortable putting parentheses around them, you can. You know, take a line, add it to a line. And when you put your like terms together, you get 5x minus 3, which is also linear. It graphs a line totally different. It's just interesting to see that taking a line and adding it to a line, you end up getting a linear equation, and that's it. Now we'll look at some that may have some other things to them here in just a second. But and I may just stick with lines so that they don't get real complicated for you. We can subtract them. Let's take these and let's do, oh, I didn't show you the other way they can write them. You can actually write it, let me erase this. You may see it written like this, f plus g of x, and I think they usually put that one in parentheses. So f of x plus g of x is like f plus g of x, same setup as you're working through them. And then subtracting, which we know is not commutative, so we have to be careful. It can be f of x minus g of x. It could be f minus g of x. And we would literally have 2x plus 1 minus 3x minus 4. Now, why do you need the parentheses? Because you've got to distribute that negative 1. So I've got, which I always like to show it, I've got 2x plus 1, just had a 1 in front of it, and then negative 1 distributed would be minus 3x, and then negative 1 times negative 4 is plus 4. So 2x minus 3x, negative x, negative 1x, or just negative x, and then positive 1 plus 4 is positive 5. Now, what if you turn that around? We know it's not commutative, so if I take g of x and subtract from it f of x, are we going to get the same thing? We ended up with a positive slope. When we subtracted them, we got a negative slope here. Now, let's turn it around and do 3x minus 4. Minus 2x plus 1. You have to have the parentheses negative here so that you can distribute it. So positive 1 in front of this, and then distribute minus 2x minus 1. Now, like terms, 3x minus 2x is 1x, and negative 4 minus 1 is negative 5. Look how those are the opposites of each other. It's kind of interesting. Multiplication. Lines are good ones to do. You can see it f of x times g of x. It doesn't look like a dot. Or again, f times g of x. Just don't let that notation confuse you. And in this case, f of x was 2x plus 1. And g of x was 3x minus 4. Well, look, if you multiply binomial times binomial, you've got to distribute. And when it's just binomials, we say FOIL it. So I've got 6x squared minus 8x plus 3x minus 4. And we can clean it up. And we get 6x squared minus 5x minus 4. Okay, division. Now division, and again, you may see it written. I don't think you would see it much like this, but you obviously could. Sometimes you'll see it f of x over g of x, and you may also see it f over g of x, like that. And they all just simply mean division. Well, in this case, f of x is 2x plus 1, and 3x minus 4 is your g of x. And there's not anything I can do to that. GCF is 1. There's no factoring. There's no canceling. And I don't give you a lot of division simply because of that, because a lot of times it's just going to be the function over the function. Okay, the new operation is called composition. Now think about it. If you take the functions that we have, we're using f of x is 2x plus 1, and g of x is 3x minus 4. Okay, if I ask you what f of 5 is, then we're going to take 5 and put it where we have an x. So we're going to evaluate it with 5. It's just taking the line and putting points. Because when you put 5 in, you get 2 times 5 plus 1, which is 11. So if we're graphing it, we know that when x is 5, y is 11. You might even see something like this, and this is more common as you get into the upper math classes. You might see like g of a. Well, again, if you did f of a or f of 5, you put a 5 in. So if I want g of a, you're going to put a in for x. So you get 3a minus 4. And I know that doesn't seem to make a lot of sense to you, but that's what it's asking you to do. So what if I ask you for f of g of x? Now think about what that means. Okay, if f of 5 means take 5 and put it in for x, then if I say f of g of x, that means take g of x and put it in for x. So I've got my, look at your function, 2 times x plus 1. So we're going to put g of x where x is. But what is g of x? There's g of x right there. So we're going to put g of x. We're going to take the x out. It would be like me saying f of 3x minus 4, because you want to put the 3x minus 4 right there. Now look what happens. Okay, you take out the x and you put in its place g of x. That's what that's saying. Now that's not the only way they write it, and I think that's probably the easiest notation to understand. And then how do I clean that up? Well, let's distribute first. And I get 6x minus 7. Okay, so what if I said what's g of f of x? Now, what is it asking me to do? G of a, we put an a in for x. So I've got g of f of x. They want me to put f of x in g of x right there. I mean, technically, I guess you could do it like this. 3 times f of x minus 4, because you're going to put f of x in for x. Well, what is f of x? So I get 3 times 2x plus 1. See, put it in g of x minus 4. Which is 6x plus 3, I'm just distributing, minus 4, which is 6x minus 1. Now, instead of writing it like that, which is easy to understand, sometimes they write it, and probably more common, the composition symbol is like an open dot. It might say, let's see, like on this one, it might say F composition G, well, let's do it like this. F of x, composition G of x. Okay, that's the same as this. You're putting G of x into F of x, and that gets a little confusing because you think, well, which one am I going to put into it? But it's the same setup. You're going to put G of x into F of x. This one is the same as G of x of, that's an open circle, F of x. And that's where you're going to put F of x into G of x. Okay, let's try a different setup. Oh, I tell you what, let's do one more. I want to do it on this level. Let's do f of x, composition f of x. Now, that would be f of x. Okay, what are they asking me to do? They want me to put f of x into f of x. So think about it. If f of x is, let's write it right here, f of x is 2x plus 1. And we're going to take f of x and put it in for x. So it's like 2 times f of x plus 1. I'm putting f of x in for x. Well, what is f of x? 2 times 2x plus 1. Okay, so I would have f of x plus, so I put f of x in for, I put 2x plus 1 in for f of x. So now I've got 2 times 2x plus 1 plus 1. We've taken this and we've put it in the place of the x. So let's clean it up. Well, I can go ahead and distribute. I had to get a different pencil. I kept breaking the other one. And so I get 4x plus 2 plus 1, which is 4x plus 3.